Hello everyone, welcome to study of ordinary difference equation, whereby we are looking at the equations which are exact. So here you are supposed to solve the following equation. You are supposed to solve the following equation. You are given this equation in bracket 2xy multiplied by cos of x squared minus 2xy close the bracket dx plus sine of x squared then minus x squared everything dy. So the first thing which we do, it is to check whether this equation is exact or not. So that is the first thing which we are going to do here. So we are going to write it, the function where dx is, it is the function of form of mx of y. In case we are here, we are given 2xy cos of parabola x squared. Then from here now we get partial of m with respect to y, which will give us 2x cos of x squared. That is a part you have left here minus 2xy. So here minus 2x. That is the result we obtain. Then when our n is this function and dy is, it is sine of x squared minus x squared. Then we get partial of n with respect to x, which will give us 2x cos of x squared minus 2x. Minus 2x that way. Then after that, you compare partial of m with respect to partial of y. You check whether it is equal to partial of n with respect to x. And in our case, is equal to 2x cos of x squared minus 2x. So it means that our given ODE is exact. Our given equation is exact. So if it is exact, then we are going to make use, we are going to seek the solution of the form f of xy is equal to constant c, whereby the factor of f with respect to x plus the factor of f with respect to y dy is equal to 0. So then we compare our partial of f with respect to x from the given ODE is 2x cos of x squared minus 2xy. So that is what we are given. Then from what we are given, what we are going to do is that plus to integrate this equation, both signs. This can be written as partial of f, which is equal to 2x cos of x squared minus 2xy d of x. Then you take integral both signs of this equation. So when you differentiate and integrate, we are going to get our function, which is a function of x and y. Then when you integrate 2 of x cos of x squared, the result here will be sine of x squared minus, when you integrate 2xy with respect to dx, the result will be x squared y plus your function of y. You can call this equation 1. On how to do the integration here, you can check in my YouTube channel on Calculus 2. I have done a number of examples for you so that you know how we are getting the result of this kind. How are we arriving at the result that when you have 2 of xy, there is y there, 2 of xy cos of x squared minus 2xy, the result is what we are obtaining there. So on how to integrate that, kindly check in my YouTube channel so that you may see how that has been worked. Then from 1, we differentiate partially 1 with respect to y to obtain the following. So there will be y here. So we are going to obtain sine of x squared, because y will, when you differentiate y, you will get 1 times this, it is 1. then minus x squared, then plus g prime of y. Then we are going to compare this with what we are given. df of dy is equal to sine of x squared minus x. We are going to compare and we are going to equate. The left hand side is the same, so we can equate the right hand side of those two equations to get sine of x minus x squared, which is equal to sine of x squared minus x squared. You can plus g prime of y. This is what I'm equating. The left hand side is equal, so I'm equating the right hand side of this equation and this other equation here. You can see sine of x squared will cancel, and also x squared and x squared will cancel, meaning that our g prime of y is equal to 0. Then we integrate these equations both sides to obtain the following. So g of y will be equal to constant c. You call this 2, equation 2. Then you substitute equation 2 in 1. 1 is here to obtain your result. So our final result of the given ODE will be f of x, y is equal to y sine of x squared minus x squared y plus constant c. Now we can check our working. You simply get partial of f with respect to x. This will give you 2xy. Differentiate sign, it will give you cos of x squared minus 2xy. Then from there, you write your partial of f of y, which will give you sine of x squared minus x squared. Now, then now you write your equation in this form: m of, or partial of f of x dx plus partial of f dy dx will give you 0. Now, when you take this one and the other part with what we are given, then they own, meaning that our working is correct. Our working is correct from the checkup we have done there. Bye-bye. Thanks so much for studying the exact difference equation with me. For other working on the difference equation of first order, kindly check in my YouTube channel. For those who have not yet subscribed, kindly consider to do so as we continue learning together. Also, for more examples, you can check in my YouTube channel, whereby I have done a number of examples for us so that we can familiarize with this working. Bye bye. See you in the next presentation.